Hey, welcome back. In the last video, we introduced packaging, and one of the advantages I told you that packaging has is that it helps resolve the weirdness that is the Python import system. So let's talk about that. As you start to scale up a code base, there's only so long you can make a single file before it just becomes impossible to consume. And so at some point, you're going to want to split out your logic into different files. And when you do that, you're going to have to use import statements to bring functions and classes and variables and whatnot from other files into the file that you're wanting to consume that shared logic in. So here in VS Code, I've made two neighboring files. I have one called my file and I have one called my other file. In my other file, let's make a variable called constant and I'll make it a string. Constant equals hi. Okay, cool. And then in my file, I'll write from my other file import constant, and VS Code already knows that that's valid, which is great. And if I say print constant, then I can run my file, and yay, it printed out hi. So that's good. It looks like in this case, imports work completely as expected. Okay, what if we add a folder to this? So here in VS Code, I'll click the add folder button, and I'll call this folder my folder. And then in my folder, I'll create another file called my nested file.py. And now I'll make a new constant in here. So constant equals hello. And now in my file, I'll say from my underscore folder dot my nested file import constant as constant2 or something. And then I'll print out constant2 below constant. And you get the point. It works, and we've been able to pull that constant value from the nested file within a folder into this file right here. Okay, cool. So the thing to point out here is that the import we just did is from a file in a higher level in the file tree, importing a value from something nested deeper in the file tree. But can we do that in the reverse? The answer is no. Python does have a concept of a relative import, so we could try that syntax. We could say from my other file, import constant as constant2. And then in this file, we could try to print out constant2. And now if I run Python space my folder / my nested file, we get an import error. And the error is we attempted a relative import with no known parent package. So we're already getting the sense that maybe if we had a package, this import statement would work. And I do want to say right now that even if we had a package and we can get this import statement to work, I still would never recommend you use this relative import syntax ever. And that happens to be one gripe I have about developing in JavaScript sometimes, is that when you write code using Node.js, it can be a little tricky to structure your projects to not use relative imports. But Python's essentially going to make us use the alternative to relative imports, which is absolute imports. So we'll get to that in a second. In this case, we tried to import something from a file higher in the hierarchy into a file more deeply nested in the file hierarchy. And why would that be? Why would Python work that way? To me, it doesn't seem reasonable. Maybe if you think of a hierarchy as a tree of abstraction and deeply nested modules shouldn't really be drawing things from higher level modules, then that might make sense. But in general, Python's known for being a flexible language. So even if that were a valid reason not to be able to import higher level things from lower level things, this is Python we're talking about. Python usually gives you workarounds so that knowledgeable users, in exceptional circumstances, can bend conventions. It turns out there is a way to accomplish this right now, and it's a total hack. I'll make fun of data scientists again. It was absolutely a wizened senior data scientist who taught me this trick when I once asked how I could import one file from another. And to be fair, technically it does work. So I'll explain the solution now. In a previous video, I talked about a variable in the bash terminal called the path variable, and Python has something very analogous to that. So let me just remind you what the path variable is. If I say echo $path, then you can see this colon separated list of directories on my machine. And one of those directories is this pyenv-shims folder. And if I type which Python, we can see that if I were to type the Python command, bash, or I guess Z shell in this case, would loop over from start to finish this colon separated list. And the first folder where it found an executable program named Python, it would stop there and that's what it would execute. So in a sense, in Z shell or bash, this is how imports work. When you type a command, this is sort of an import process by which the executable, or we could call it a module in Python terms, is discovered and then loaded in, or in this case, executed. Okay, well, Python uses something similar to discover importable modules. And this is as good a time as any to define what a module is. A module is a single piece of an import path in Python. I don't think it's the most accurate to say that a module is a file, although any file that ends in .py is a module. But folders can also be modules too under certain circumstances. Specifically when you add a double underscore init.py to them. If I were to add a double underscore init.py, then I could put values right in here. I could say a equals 1, and then in my file, I could just say from my folder, import a. So thanks to this init.py, this folder is acting as a module. So, okay, back to the original problem. How can we make it so that from a nested file, we can import a value from a file higher up in the file tree? I told you about the path variable that Bash and Z Shell use to basically search for programs. Python has a variable called the PYTHONPATH variable, which is also a list of folders where Python looks for modules when you do these import statements. Hey. So watch this. Instead of doing a ... right here, I know that the name of the folder that I'm in is packaging. So what I'm going to do is I'm going to get the absolute path to packaging on my computer. And so the way that I'm going to do that is I'm going to write pwd. So this is the absolute path to packaging. And now I'm going to execute my program again, but this time I'm going to do Python path equals $Python path : and then this path value right here. So what this is basically doing is taking the original value of Python path, and then it's appending this extra path to it, this packaging path. Okay, cool. And right after that, I'll type Python, and then my underscore folder, and my nested file.py. So I'll be directly executing this nested file. But I'm not going to run it quite yet. I'm going to do one last thing, which is I'm going to add an import statement. And that's actually all we should need to do. So I'll run this right now. And it worked. We imported hi. How does that make sense? You can see if I just run Python my folder my nested file.py by itself, that import doesn't work. And I'll run it with that extra Python path value one more time, and it worked again. Well, there it is. Python path is behaving exactly like the path variable does for the Bash or Z Shell interpreters, except in this case, it is allowing the Python interpreter to locate Python modules. So for any folder that's in the Python path variable, any direct children of that folder can be imported as a top-level absolute import like this. So watch this. If I were to add an init.py file to the root of the packaging folder, so at the top level of the packaging folder, I could rerun this command, but instead I could just add my repos folder to the Python path, not packaging, but just repos. And then in this deeply nested file, this my nested file, I could say from packaging my other file import constant as constant2. So let's run this one. It totally worked. And now in this case, even VS Code's confused why this one worked. But yes, the point I wanted to make here is that because packaging is a direct child of repos, we can use the folder name packaging as a top-level import in our Python code. And that's because we've sort of surgically added it to the Python path. This video is getting long, so let's consider this part 1 of how imports work in Python, and in the next video, we'll finish with part 2. See you there.